Hi, my name's Eric Wetchin. I'm a Principal Product Marketing Manager at MathWorks. I'm excited to be at IMS, and I'm going to show you a 5G waveform validation demo today. So we have a couple of apps that help make this really easy in MATLAB. So first I'm going to show you the wireless waveform generator app. So with this app, you can generate a 5G NR signal and cause it to come out of the signal generator here. So I'll show you how that's done. So we'll go to the generator tab of the wireless waveform generator app, and you can see all of these signals can be generated in MATLAB. So you can do 5G, LTE, WLAN, and so forth. So in our case, we're going to focus on the 5G NR test model, and we can configure things like what type of signal we want to send. In this case, we're going to send a 256 QAM signal, and we can configure the channel bandwidth, the subcarrier spacing, and so forth. You can also do things like add impairments, like phase offset, you can add frequency offset, you can add noise. So all this is built into the app. You can then generate this signal, and you'll be able to see a preview of what the signal would look like. Here we're still in the math domain, we haven't sent anything to the instrument yet. Once you have all of that set up, then you can go to the transmitter tab, and you can connect directly to the instrument by choosing the IP address of the instrument. You can then configure the center frequency as well as the output power. So we've done that here, and then we're going to hit transmit. But before I hit the transmit, it's important to note there's this, you can export a MATLAB script that will basically give you the MATLAB code that contains the signal content as well as the instrument connectivity. So I'm going to transmit the waveform. And now the waveform is being downloaded to the instrument. So in our simple setup here, we're basically sending a signal over the air from the generator to the analyzer. So I'm going to go into the other app, which helps out for this. It's called the Wireless Waveform Analyzer app. And in the Wireless Waveform Analyzer app, you can see, again, you can connect directly to the instrument. So in this case, that's the signal analyzer on the bottom. And you can set the center frequency and some of the other parameters for the capture. You can also, and this is quite important, you can do impairment corrections with this app. You can do timing correction, coarse and fine frequency, offset correction, and some other corrections. So we're going to select the first three here for this particular example. And then before you capture the waveform, you can use this waveform configuration. This tab here will bring up a window, and there's some presets for the 5G. So since we're working in 5G, we want to make sure that we match the same 256 QAM signal here and set the subcarrier spacing and the bandwidth to be the same as we had on our previous generator. So we apply that, we accept that configuration, and now we should be ready to capture the waveform. So then we go to the capture waveform, we click capture waveform. It takes a second or so to grab that data from the instrument, and then we click analyze. And you can see there's the signal, there's the constellation plot of the 256 QAM signal, and we can see the error vector magnitude, the peak error vector magnitude, as well as the EVM as a function of the slot number. So with these two apps, it's very easy to validate your 5G waveform, whether you're doing over-the-air testing or doing some kind of component testing where you might just care about the signal generated or just care about the IQ data that you're collecting. For more information, Google 5G Toolbox or Instrument Control Toolbox, and you'll see a number of examples related to this demo. Thank you.